You're at the right place if you're interested in ontologies, T-box, A-box, lexicons, structured knowledge, all of that. What I'm going to do now is describe to you some things about what I call the symbol grounding framework, or SGF, the symbol grounding framework. Symbol grounding framework is several layers, and I'd like to talk about the first layer. The first layer is taking free-form text, which I'll call prose, P-R-O-S-E, that could be like from a Wikipedia article, it could be from a white paper, an essay, a corporate document, maybe a legal document, and transforming it into structured knowledge. The structure is like a hub and spoke bicycle wheel, where the verb is at the hub, very important, verb at the hub. And out on the spokes are the other things in the, I almost started to say sentence, but I'll say clause, C-L-A-U-S-E, is the most compact atomic form of thought. The unit of thought in the symbol grounding framework is the clause. Okay, the nodes around, in orbit around the hub of this bicycle wheel, hub and spoke format, use 15 relations that are borrowed from what's called thematic relations, where you can take a sentence or a clause and deconstruct it into who is doing the action. They call that the actor. Who is the action being done to? That's called the patient. And what was the reason or the purpose of this? What time this occur? There's 15 of these relations in thematic relation theory. Thematic relation theory, and that goes all the way back to the 1960s, 70s, and then in the early 80s, Chomsky. Okay, so we're taking prose, we're deconstructing it into clauses of each sentence and formatting those in a hub and spoke format that we can then put in a database, and I'll explain later what that's all about. There's also a lexicon, so you know the whole T-box, A-box. T is our terminology. What do words mean? That's our lexicon. A is the assertions, the claims, the statements that go into this structured format. We've got to have both because language is both vocabulary and grammar. This hub and spoke format structure in symbol grounding framework provides the grammar, and it's a fixed grammar, not an open grammar like RDF is open, where really anything goes. Okay, 15 roles gives us the fixed grammar, the verb in the center, so it's really an event type structure. But we need to know what do the words mean. So if we just start we load this into a knowledge graph and we just start dumping words in there, well, words can have lots of different meanings because of what's called polysemy, one word, many meaning. I'll give you some examples. If you look in the Wiktionary, which is a dictionary derived from Wikipedia, you look up the word bank. There's 40 entries for bank. So bank would be what we call our lemma, L-E-M-M-A. Symbol grounding framework uses for its dictionary or lexicon, which we can use kind of synonymously for a moment here, the free open source downloadable Wiktionary, which has in its largest form 1.7 million terms. And we can take that and bootstrap it into something that's going to be very useful, besides just giving us the definitions. But in its simplest form, this Wiktionary-derived lexicon is going to give us a way to look up every word and have a meaning. So like if we're using the word bank, we need to know which of those 40 variations of bank we're pointing to. So we need a key that points back to the lexicon. Okay, symbol grounding framework provides that key. Now, the Wiktionary lexicon in its basic form doesn't have a hierarchical structure that we need. And what I mean by hierarchical structure, let me give you this example. If you think about it, language is really compression. It's very inconvenient, takes a lot of time to write or say. Every time we want to have the concept of a wagon, to say a platform usually with sides that forms a container attached to an axle with wheels and a hitch so that it can be pulled usually by animals such as a horse or oxen. So we just say wagon, and that's what language is. It's really compression. And if we can realize that language is compression, then we can, by using some clever coding, and I code in Python, we can build a decompression map. So we can take a word like wagon and with the help of an LLM, burst it into, deconstruct it into the components. And that's where the ontology comes in. So we'd have ontological things like the ISA, the taxonomy. What is this thing? Like calico cat is a domestic feline, right? Do you see the pattern there? And has part, HAS-PART. So wagon has part, axle, wheels, hitch, platform, etc. Okay, so by running some logic and bursting this lexicon into its each thing into its component parts, we now have something that can be reasoned over by machines. And so machine A and machine B, when they're looking at a specific word, they can look and see not only, well, what's the word, but what are the component parts of it, and compare. So I would call that where we're comparing definitions from party A and party B. We could call that ontology alignment. Okay, and that's going to be very important for problems like what I like to call the NASA screwdrivers. So imagine NASA, or it could be any government agency, FEMA, Department of Defense, whatever. They need to procure some item, we'll just say a screwdriver that has very special properties, such as it needs to operate in Arctic conditions, underwater, zero gravity, be made out of titanium, whatever. And the vendor that's supplying this is going to have product catalog with description of this thing, and the procurer that's purchasing this special screwdriver needs to have their requirements of what they need it to be, and then we would compare item by item to see, do these align? Well, having a hierarchical lexicon allows that to be possible, so that we can navigate not only from the word screwdriver, but down to what are the things it's made of. And so the symbol grounding framework starts with the Wiktionary lexicon, and there's two forms of it. There's the 1.7 million term version. There's also a smaller one with about 72,000. Now, there's scripts that I've created in Python that I've posted up on my Git repo, and I'll put the link at the bottom of the video in the text, so you can go to that, follow that link, and find and download the code. So the instructions are there on the Git repo to show you how to download the Wiktionary. It comes in a JSON file, and then run these scripts, and it'll load it into a database. I'm using SQLite, that's SQLite, because it's free, very lightweight. You don't have to install a database. It's all self-contained as a file. So it's going to load this data from Wiktionary into a SQLite database, and then there's other scripts you run that are going to do things like build the embedding, map out with the help of an LLM the component concepts, things that this is built up. Now back to this idea I was talking about, a hierarchical or deconstructing, decompressing. So like if we think of language as compression, we use one word to mean something else. Then we can go the other direction and decompress instead of compressing, and build a decompression map. And ultimately, if we follow this decompression all the way to where it ultimately leads, we end up at 65 words in the language that cannot be decompressed any further. The linguists have studied this and identified 65 words. They call them the primes, the semantic primes. And this works across all languages that they've studied. They've studied the major languages, European, Asian languages, but also gone into primitive tribal areas, studied their language, and found that everything gets down to these prime words and concepts. And to explain what prime is, think of like prime numbers in math, like 5, 7, 11. You can't divide it by anything except 1. Okay, so it's indivisible. A number like 12, you can divide by 6, you can divide by 3, you can divide by 4. It's not a prime number. Okay, so a prime concept. So if we're building a map for machines to reason over, we wouldn't want to have circular relations like, for example, happy means glad, glad means happy. You're just a merry-go-round there. It's not leading to anything. Okay, so this building this map of the language is motivated to build it in a way so that everything is always going to its more abstract, or I'll call the parent concepts. Okay, and another thing I want to emphasize is that, like, go back to Calico Cat, you could say it's a mammal, you could say it's an animal, you could say it's a thing, but that's too abstract. You want to find the abstract thing that is closest. So the closest thing to a calico cat would be domestic feline. Okay, now, so we build this map, and then we can do wonderful things like compare our screwdriver, our NASA screwdriver, so that if we order the wrong one, we're not going to have to launch another. You know, they get up into space and find out this isn't the screwdriver we need. Oh, you've got to launch another mission at a cost of millions of dollars to send the rocket up with a replacement screwdriver. See, so where consequences matter, you'd want to use this ontology that's got this hierarchical mapping of language to be able to compare one thing from party A to what party B believes a word means. Now, this becomes very, very useful when we're doing like RFPs. A request for proposal goes out maybe from a government procurement office, and the suppliers have their catalogs of all these things, and they put together from their catalog a proposal of all these items, and we need to compare all the items in the proposal versus what are the items in the RFP, and it could be very, very complex. And so if we have this kind of lexicon that the symbol grounding framework builds, then you'd be able to easily build scripts that can like burst the RFP and burst the proposal into like a hierarchical structure, and then just it's a matter of navigating through this and finding where things line up. So I've talked a lot about so far the lexicon and the hub and spoke format. There's something else that I want to mention, and that is this whole idea of what I call knowledge packs, where if we take information and we put it in an LLM, it's all just baked into the weights of that LLM. You can't really see it or inspect it and take it out and look at it. You just see what comes out when you ask a question. And so it's not really transparent or visible or auditable. But if we take information and we put it into these structures that I've talked about, the hub and spoke format, then we can have it in a database so it's visible. So we can build a knowledge pack of things using the symbol grounding framework of things like, imagine the laws of Louisiana. I'm in Louisiana, so it could be like the civil laws of Louisiana, criminal laws of Louisiana, laws of the city of New Orleans. We could have a knowledge pack for like laws of aviation, laws governing shipping, laws governing drilling on government lands or offshore. And so we can have these knowledge packs, and really what I'm talking about is things that can be done in the future if you're using the symbol grounding framework to structure your knowledge. And so we can have these containers of knowledge that are visible, inspectable, transparent, and you can also have provenance stored with each fact of where did this fact come from. Another thing I want to mention is that the clauses that are extracted from the prose come in two forms. One is what I'd call atomic, and the other is molecular. And this is very important. So some standalone fact that is totally meaningful by itself without the benefit of any neighboring information I would call atomic. Like if you look in a Wikipedia article, You see Beethoven was born, Ludwig van Beethoven, the composer, was born on December 16th, 1770. That fact can stand alone as meaningful by itself. As a clause, the CLAUSE, a clause mapped into one of these hub and spoke formatted structures. But instructions for how to bake a cake is not going to fit in one clause, so it's not atomic. It's got a lot of atoms in it, but they need to be combined to form what I think of sort of analogously as a molecule. So then we can have two kinds of structures in this database, the atomic and the molecular. And SGF has the linking mechanisms that allow us to make connections between these atomic things that really form something that's more molecular. There's 5 different ways of linking them. Sometimes we want to link things, for example, in a way where it's sequential, right? Step 1, step 2, step 3, step 4, etc. Okay, and then these things that are formed can also be aggregated into larger units where we're combining these molecules into even bigger things. And the word that SGF uses is for these atomic things is synapse, S-Y-N-A-S-P-E, synapse. I think I've spelled that right, synapse. And then when we have the molecular one where we're joining synapse, that's synapse groups. Okay, so each thing in a synapse is going to be the hub and spoke format with the verb at the center, and then the other things in the clause in orbit around it, like the spokes on a bicycle wheel. And we need to link those back to our lexicon. And so there's a key that's used that's called a canonical ID, like canon, canonical ID. And the canonical ID is both human meaningful and also machine meaningful. And it's based on taking the lemma and the gloss, and I'm going to explain all these words, and the part of speech, and then some other things. So what is a lemma? A word like bank, banking, the past tense banked, or the banks, like plural. When we take and find the most basic form of this word, that's called the lemma. And the lemma for all those words would be bank, B-A-N-K. So a dictionary is going to have the entry with the lemma, B-A-N-K. And as I mentioned earlier, for bank and Wiktionary, there's 40 different forms. Okay, and so we look at the gloss. Gloss is just a fancy way of saying the definition. The definition for each of these lemma entries is going to tell us what meaning or what sense of it. Okay, so we could say a bank is like an airplane, a jet is doing a maneuver where it turns to the right or the left, is banking. Okay, that's one form. Another is a business where depositors are depositing money or borrowing loans. Okay, so that's another form. Or we could also say like the water's edge. The water's edge on the side of the river or a creek is a bank. But we want to have a key in our system that is human meaningful, and those long explanations are too meaningful. So symbol grounding framework has what's called a microgloss. It's a small, short, terse gloss of 2, 3, 4, sometimes 5 words that clarify. So for example, we could say bank as our lemma and water's edge. We'd know what that is. We know that's not where we go to get a loan. Or we could say bank, aeronautic maneuver. And so as we form these keys that are meaningful, we're going to have the lemma and then a delimiter using a period, or I'll say dot. The lemma, a dot, and then this microgloss. And that gives us the key. So we can say bank, dot, aeronautic maneuver. And if we want to further qualify it, which we should, we'd also include the part of speech, which is like, is it a noun, a verb, adjective, adverb, etc. So we could say aeronautic maneuver, bank, dot, aeronautic maneuver, dot, verb, right? Banking, that's a verb, okay? We further want to further qualify it by having a prefix that shows which language is this from. We use the ISO language code, which for English would be EN. So we'd have EN dot bank dot aeronautic maneuver dot verb. That forms a canonical ID. There's an optional but highly recommended additional object in this canonical ID, and that's called namespace, which tells us which lexicon did this come from. Is it the Wiktionary lexicon? Well, which Wiktionary lexicon is it? It's published monthly. So this being June 2026, we could say Wiktionary and then maybe an underscore or a dash 202606 to show year and month. Okay. You're also going to want to have some private lexicons for terms that are unique to your business or your industry. So we'd say these are domain-specific lexicons. You might also want to have a lexicon that's specific to some terms in a group of documents or even an individual document, like names of some people. If this is like imagine you're processing some documents for a class action lawsuit. So there's going to be names of defendant and witnesses, etc., businesses that aren't in the general language. You want to build a custom lexicon and have all these terms in it, assign them canonical IDs, have some glosses for them, etc. Okay, and so having the namespace tells us which lexicon did this come from. So our canonical ID has the language code, the lemma, the microgloss, the part of speech, and the namespace. Five objects in it. So we have something we can put in our knowledge graph instead of just putting the word bank in there, which creates tremendous confusion in knowledge graphs when they want to run queries on it. So we have a unique identifier that is human readable but also machine readable and connects back to our lexicon that in the normal case is going to be the Wiktionary derived lexicon. If you have special words, as I said before, you'd want to build custom lexicons for that. You don't want to mix them in with your Wiktionary lexicon. You want to have your custom miniature lexicon, give it a name, and you identify that in the namespace. Now, we've covered the structure. We talked about RFPs and having a hierarchical lexicon. I think that's a lot to cover for today. I just want to let you know, though, that SGF is really a stack for the future of intelligent machine cognition. And I've just given you the foundation of the stack, which I call the substrate. There's other layers on top of that, and I'll just go through those quickly. One of the layers is a machine-to-machine communication protocol. So like once we structure information in these synapses and synapse groups, we can send it from one machine to another, and the machines need to be able to trust what machine did this originate from, can I trust it? So we've got the encryption and all of that, the keys that show this came from a trustworthy source. And the assumption is that if we use these canonical IDs and we're pointing to this shared lexicon that anybody in the world can download easily, we don't need a central committee somewhere to tell us what words mean, then we just need to have the pointer to the canonical ID. But if we're sending some words in the message from computer A to computer B or machine A to machine B, or it could be robots, drones, whatever, that are communicating, and they have some specific vocabulary, well, machine B is probably not going to have this additional lexicon that machine A has unless they have shared in advance. And so what SGF has you do is have a data section in your message that has the micro lexicon of just the terms that are used in this message that are not in the shared core Wiktionary derived lexicon. So clarifying terms travel with the message. And what this makes possible is two machines to communicate with each other without prior integration, because everything is grounded. That's where the word grounded comes from in symbol grounding framework. Every word is grounded. And when we're building these custom lexicons that extend the core language into terms that are specific to our business, our industry, or a group of documents, all of those must be grounded back to, so like if you, back to the core lexicon. So if you give someone's name, for example, it's a person, it's a man, so you'd need to have this taxonomy relation is a man, okay? Whatever that canonical ID for that would be. If this is a business, it's the name of a business, then you need to have the canonical ID for the business, you know, with the fully qualified ISO language code, the lemma, the microgloss, the part of speech, etc. So everything ultimately ties back down to the core lexicon and goes down to, ultimately terminates at the 65 semantic primes. And so everything is grounded. So this is a key thing about why SGF is called grounded. Everything grounds. So we've got this protocol for machines to talk to each other built upon the substrate. If they structure the communications using these synapses and follow this protocol, and the specifications for the protocol are on the Git repo. They're in an RFC form, formal request for comment form. Then we can do lots of wonderful things. There's another layer to this, and it's a governance language, and I call that governance language Omega. Omega has 13 primitives that specify what a machine can and may and do. So we wouldn't control the machine's behavior by just what's baked into an LLM that's having the machine make decisions. We would want to have governance rules that are in an inspectable language, and that's what Omega does. And then there's another layer on top of that that describes what an AIOS should be like, that's operating with these other layers underneath it. I'll share that in another video at another time. I just wanted today's video to just give you some insights into SGF and go into the lexicon and the synapses. And I'll be posting some more videos soon that'll go further into all of these details. I'm just sharing a lot, big picture, to kind of help you understand. Now, if you look on the Git repo, you'll find the formal specs. You'll find some essays that'll explain all about SGF. I've also written 6 books that I call the Symbol Grounding Framework book series. 6 books there that go through the whole stack. The first book is a primer. It's called The Napkin Pitch. It's like a little drama. You know, sometimes you can teach something by telling a story. So it's in a story form. And the idea of the napkin pitch is like someone showing someone in a restaurant. They take out a napkin and a pen and write on the back of the napkin, sketch out this hub and spoke format. So the napkin pitch is a good place to start. You can get those books on Amazon if you search for Symbol Grounding Framework. I'll also have the link below. You can also get the books free. They're in PDF form. They're on the Git repo. I'll put the link to that too. So why would you get the book from Amazon if you can get it free? I guess just if you want to read it on the plane, or you like me, like to have a book that you can actually open and feel and touch, just like the feel of that. So I want to say thank you so much for listening, and I very much would like to offer you, make you feel welcome to reach out to me, make comments. I'll also leave my LinkedIn connection. I'm on LinkedIn. If you want to send me a message through the LinkedIn chat, I would very much look forward to hearing from you. I would like to say thank you so much for listening to this and looking forward to the future.